what does IEC 61511 mean by competency, and what is competency in general? To me, I've always viewed competency as being a blend of knowledge, experience, and capability. Obviously, when you need the knowledge, we need to know, but we also have to be able to apply it. And this is where this is the important part, is being able to apply it in a way that is efficient and effective. So why is it important? Well, some of you, again, may be very familiar with this famous pie chart that was produced by the HSE when they looked at the causes of accidents. And what we can see is the majority of the cases, over 50%, was caused due to a bad design or a bad implementation. And here again, when we look at accidents, in the majority of the cases, it's normally due to some form of systematic issue. And when I teach the FSE 100 class, I usually characterize systematic as being what we call the 3 Ps. The 3 Ps are people. Number one, do we have people who are properly trained and competent to do the work? And secondly, do we have clearly written procedures that are being followed? And thirdly, do we have a paper trail to prove that we're doing what we're supposed to be doing? So obviously, when you look at this pie chart, you can see, and if we just focus on the front end, we can see that the bad specification or implementation can be a combination of one or all 3 of the 3 Ps. So this is very important, and being able to manage the systematic is a very important part of this overall process as we go through doing safety systems design. Now, if we look at the life cycle, the 61511 life cycle, we know that there are 3 phases. There's an analysis phase where we do all the risk analysis and determine whether we need additional protection, and if we do, is that protection going to be requiring safety instrumented systems with safety instrumented functions and given SIL levels for the risk reduction. And then we go into the design and implementation, where we created our SRS in the analysis phase, we implement the design and implementation phase, and of course do all the verification and validation. And then finally, we go into installation commissioning, do our final checks, and hand it over to operations, and it goes into the operation and maintenance. And it's a cycle, it's not a once and done. So if we look on the left-hand side, we can see management of functional safety and functional safety assessments, and of course planning. So this is very important because this, as again I like to characterize it, if you think of this as the glue that holds it all together, if we don't have proper functional safety management systems and procedures in place, and we don't have properly trained and competent people, we're very quickly going to become unstuck. And again, the primary purpose of this is to help us manage our 3 Ps, so we don't allow systematic issues to creep into the overall analysis and design process and the implementation. Because if we do, then we could have problems further down the line, especially if we're not doing the proper functional safety assessments to help us identify if we have any systematic issues. Then of course it becomes more expensive and potentially disastrous further on down the line. So this is the purpose. And of course the life cycle itself is to help us build safer systems that don't experience a lot of the problems that we've had in the past. And of course to help us build far more cost-effective systems. In other words, we balance the required risk reduction with the system design. And if we do it right, it will actually save us money in the long run, because we'll have less potential problems with downtime as a result of either trips or systematic issues where the personnel aren't properly trained or the procedures aren't right, and that causes us to trip, or worse, it causes us to have an incident. And ultimately, that can become very expensive if we have a major accident. We also want to make sure we don't have weak link designs. And if we do it right, it gives us this consistent framework for designs across the globe. So if we've got multiple sites, we should be able to get consistent results by following the life cycle. And of course, the two primary objectives, first and foremost, we want to avoid systematic faults, and we need to reduce the potential for random faults. So these are the two primary things that we're concerned about. And competency, of course, plays into all of this. If we don't have properly trained people, if they're not competent to do the work, then that is going to have significant impact. So in the 2016 edition of 1511, it beefed up this requirement for competency. And you'll see that some of the changes was to include more normative language. The shalls, as opposed to the shoulds, are in the standard. And you can see here, they're now specifically targeting CIS safety lifecycle activities. And they're saying shall be competent to carry out the activities. Having said that, they expand on it by saying the following items shall, so again, we're looking at normative language, be addressed and documented when considering the competence of people, departments, organizations involved in CIS safety lifecycle activities. So this is far more specific than it used to be in the 2003 edition. And then it goes on to define those activities with engineering knowledge, training, and experience appropriate to the process application. So of course, we need to know what is the process, what are the relevant hazards with the process, and what protection mechanisms do we need to have in place. And of course, that will extend to the safety instrumented system with its safety instrumented functions. Then engineering knowledge, training, and experience appropriate to the applicable technology. So here again, if we're an engineering company and we are designing a safety instrumented system, we need to have the relevant people trained and competent in how to apply the technology. The standard itself says that we have to justify the equipment we choose to use in a safety instrumented system. Then engineering knowledge, training, and experience appropriate to the sensors and the final elements specifically, as well as the overall process safety analysis. So here again, if we're involved in doing the hazard and risk assessments, in other words, we're sitting in a PHA or a LOPA, layer protection analysis, do we have the relevant experience or competency to be able to participate? Especially if we're looking for facilitation. Does the facilitator have the relevant knowledge and experience appropriate to the application? Then, of course, from a supervisory or management perspective, there's knowledge of the legal and regulatory functional safety requirements. So it's interesting, when I teach the FSE 100, I usually ask the class if anyone has any life cycle responsibilities, and normally the hands go up. And then I say, okay, of you, who has responsibility for their budgets? And usually the hands go down. It's very rarely that I have people that are in there who have budget responsibility for functional safety. And when I do, it's great, because then they get an appreciation of what's involved and what specifically we have to do from a functional safety point of view to make sure that we have properly trained and competent people and we have the appropriate procedures and processes in place. It also talks about that adequate management and leadership skills for the particular role in the CIS safety lifecycle. and making sure that we understand what is the potential consequence of an event, along with the SIL for the CIF and how to determine what safety integrity level we require for the CIF, plus the novelty and complexity of the application and technology. So this is all included now in the 2016, and in particular this one and this one. So we have to have competency records, we have to have competency tracking, and we have to make sure that we're documenting it. It also then goes on to talk about making sure that we do manage the competence of those involved. And it requires us now, and the standard uses the term periodic, because of course this is a performance-based standard. It's not going to be a specific requirement where they tell you how to do it as well as what you need to do, which you would get in a prescriptive standard. So if you remember, a performance standard says this is what you have to do, but how you do it, it's up to you as long as you have means to measure your performance. A prescriptive standard will say this is what you have to do and this is how you do it. So it leaves the end user to determine how often they wish to do these assessments. So it uses the term periodic assessment. So you could say, well, we'll do that once a year, or we'll do it once every 6 months or once every 2 years. It really comes down to the end user. But we need to do it, and we need to document the competence of the individuals against those particular activities they're performing. And of course, if there's a change within a role. So we have to make sure that's properly tracked and the competency is recorded. And actually, we've been working with several companies to help them create their competency development plans for functional safety specifically. But you could also extend this to cybersecurity and alarm management if you so wish. So again, the whole purpose of all of this is coming back to managing our 3 Ps. Do we have properly trained and competent people to do the work? Do we have proper procedures that are being followed? There's been numerous instances where accidents have occurred because procedures have not been followed. And then from the paperwork point of view, do we have documented traceability of competency, the results of any testing or assessments that are done? Here again, the standard doesn't tell you how to do the assessments. You could choose to use your online system if you have a management learning system platform, or you could do it through examination, written test of some description, or you could do it through observation, using simulators or having more senior experienced personnel who are competent to be able to do the assessment. So there's a number of ways you can do it, but you need to record it and you need to be able to trace it. So in Exeter, for example, we have this 2-level competency description that we use. So, for example, in this case, we're talking about doing SIL selection workshops and leadership, but not doing LOPA. So in this case, the basic requirement would be that we would want them to have a CFSP or a CFSE, and I'll talk about the difference between that in a minute. And then for senior requirements, we need to be holding a CFSE, because usually senior requirements have much more detailed life cycle responsibilities, whether you're facilitating a hazard, facilitating a LOPA, doing the SIL selection, or whatever specific detailed task that is required. So you could use something like this. And then there's the difference between certification or certificate. So typically with a certificate, it's a once and done. It normally results from some form of educational process. If you went through college and you did a degree, you get a certificate at the end of it and you have that for life. You don't need to take another exam. It's with you for life. And this can be useful for both newcomers and experienced professionals, depending upon the level of responsibility. You can get this through a number of different programs or institutions, and it can be the completion of a single course or a series of courses. So obviously, if you did a certificate program, then there might be several modules you have to do in order to achieve the certificate. Usually the course content is determined by some provider, and it can be an institution. It's not generally standardized. Some companies have programs where they have different instructors who would create content, create the exams, mark the exams, and so on. It's usually listed on a resume detailing the education, and of course it demonstrates a certain level of knowledge of the course content at the end of their particular time, whether it's a week's course, whether it's a month's course, whatever. Whereas with certification, it's somewhat different, because it results from not just taking an exam, but an assessment process that can account for an individual's knowledge, skills, and competency in particular specialties. So this is more back to the knowledge, experience, and capability. It does typically require professional experience. It's normally awarded by a third party or standard setting organization, and it indicates a level of mastery or competence measured against a set of standards. So it would be, for example, if you chose to do certification from the process industry point of view following 1511, then you would be tested on your knowledge of 1511 specifically and how you would apply that in a given scenario. The other thing is, and I like the way I like to characterize it, because I'm fairly simple, so I like to make things simple. I characterize the certification as being the separation of church and state. So for example, I teach the FSE 100 class, and I also set questions for the FSP certificate exam, I'll talk about in a minute. And I also mark it if I'm doing it in person and they're sitting in front of me. Whereas with certification, I am not involved in the exams. I'm not involved in setting the exam questions. I have no idea what questions are going to come up if somebody goes on to do a certification class and course. And I also won't know if any of the students passed or not unless they tell me. So there's a complete separation, and it's operated independently. It results in credentials, so you can put CFSE or CFSP, for example, after your name, but it has an ongoing requirement. So the holder has to demonstrate that they're maintaining their level of knowledge and competency. And similarly to, if any of you are PEs, you know that every 3 years, I believe, you have to show that you're maintaining your certification accreditation. So you can look at the programs that are out there. There are the certificate programs, which can be provided by ISA, TUV, us, for example. And there's the certification program, which in our case is CFSE, CFSP, CACE, CACS. So you can become a certified functional safety expert or a certain certified functional safety professional by taking the certification exam and the equivalent on the cybersecurity side. So when we look at the competency requirements that are in 1511, we seem to have a nice match with programs like the CFSE program or the CFSP program. And you can look at this as 3 levels of competency, if you like. The certificate program, people can get certificates fairly there's quite a few providers, so it's fairly easy to choose a provider to get the certificate program. But then when you move on to the certification program, you will be looking at a high level of competency. So for example, at Tier 1, the certificate level, the functional safety practitioner addresses the need to provide confirmation that the student or attendee showed competency by retaining the knowledge from the course. And typically at the end of our FSE 100 class, there's a 1-hour FSP exam, which you can take online, but you need to get 80% correct to pass. And it's only based on the content that was covered in the course. So it's purely a certificate. Whereas when you start looking at Tier 2 now, if you wanted to become a certified functional safety practitioner or professional, this is a certification program that's operated per IEC 17024. And what that means is, as I've said earlier, you think of it as the separation of church and state. So the CFSE board is a separate entity. It has or sets the standard for the CFSE and the CFSP globally. So it doesn't matter whether you take a CFSE exam in the US, Europe, Middle East, Far East, the standard is the same. And it has independent assessors that will review the submitted paper, and they will be marked separately, independently, and then they would compare to see how did the two assessors grade the paper that they got. And if there's a difference, a big difference, then it would be reviewed by a third assessor. So there's a level of independence and separation, as I said, and I don't get involved in it. So I have no idea what or how somebody is doing. And in fact, there's no names that appear on the papers. It's you're given a unique number, and that number is the number that appears on the paper. So even the assessors have absolutely no idea whose paper they're assessing. So it's completely independent. And similarly with the CFSE, which is regarded as the gold standard in competency demonstration. So those are the three levels. So where would you fit if you were looking at this? Well, from the certificate programs, if you wanted to do functional safety, you could become a functional safety practitioner. If you wanted cybersecurity, you could become a cybersecurity practitioner. And the same for fire and gas. There's a specific fire and gas program. You could become a fire and gas practitioner. And similarly with the alarm management, you could gain an AMP certificate. And then, of course, you could use ISA, get the CIS certificate expert, or TUV for the FSX, or the functional safety expert. And from that, if you determine that's sufficient for the role that you have and the level that you of competency you need, that's fine. Otherwise, you could then use that as a stepping stone to go to the next phase to do the certification program. And with the CFSE, as I said, it's a much more stringent test because you have to also submit a separate case study. It doesn't have to be War and Peace. It can be a few pages, just as an example of the safety work you've done over a period of time. And there is a time requirement for the CFSE. In other words, there's a minimum of 10 years experience required. You will get 3 years credit for a degree, but you also need 7 years experience on top of that. And then you'd have to submit a case study as part of your representation, as well as sitting the CFSE exam. With the CFSP, you don't need as many years of experience. You only need 2 years of experience, and you don't need to submit a separate case study. Similarly with the CACE, which is the Certified Automation Cybersecurity Expert, you would have the same criteria for the CACE and the CACS. So those are available. Also, you can take advantages from this. So the advantage of becoming a certificate holder as I mentioned already, it provides a level of competence, proof of competence. As such, it increases your value as an employee because now you can get involved in SIS activities. It differentiates you from competitors. And of course, if you're interested in taking the next step to go to the certification, it helps prepare you for that. It also helps provide an analysis of where candidates' strengths and weaknesses lie. So for example, if you did fail the FSP exam, then you could have a review with the instructor to see, okay, where did I fail? Where did I go wrong? And that would give you an indication of, okay, I need to brush up on this area because I'm not so good at it. And then you can put the Exeter FSP or whichever designation behind your name after you pass the certificate exam. So those are some of the advantages of the certificate. From a certification point of view, again, helps increase your value as an employee, will differentiate you from your competitors or other employees. So again, working on safety instrumented systems is not something that can be just done by anybody. You have to have that knowledge and understanding of the functional safety aspects involved in doing safety instrumented system design. It could also be a specific requirement for certain work positions. Some companies may insist that if you're going to be a CIS engineer, that you do need to have a CFSE or a CFSP. You can also put letters behind your name again, so you get credentials, and it will indicate that you have a level of competency as measured against a defensible set of standards. As I've said, if we're looking at 1511, then if you do the exam, you would need to have a copy of 1511 with you to be able to do the exam. And generally, these are looked on as upon mentors or leaders in the industry when it comes to functional safety. It also means you could become one of an elite group for functional safety, because believe it or not, if you look at the number of CFSEs worldwide, there are only 771 CFSE qualified people globally. So if you think of the size of the process safety industry and functional safety itself, that's not a very large number of people. And CFSE, as I mentioned earlier, is targeted towards those senior engineer responsibilities with significant life cycle involvement. CFSP would be targeted to the mainstream engineers that are doing safety life cycle activities, but with less experience. So they might be working under a CFSE or as part of a team. I also encourage supervisors and managers to achieve some level of competency, even if it's getting an FSP, ideally CFSP, because they may be managing CFSEs or CFSPs. So they need to have a level of competency. And when we look at the number of CFSPs worldwide, we can see there's only 1,672 qualified CFSPs worldwide. So again, it's not a huge number. So you can become one of an elite group as well for, as I mentioned earlier, cybersecurity is similar to the functional safety. There are only 27 certified automation cybersecurity experts worldwide, which is very few. And for the certified automation cybersecurity specialists, there's 28. So that's a much more elite group, smaller group. Now, what are the available programs and the types of exams? Well, as I mentioned to you, there's the process safety applications, which is the 1511 based exam, which is normally the default exam. So when you go to the CFSE website, if you wish to sign up, you need to choose the right exam, otherwise it defaults to the process exam. I've had one of my previous students wanted to do the machinery exam, but forgot to put that when they signed up. So you can imagine their surprise when they were presented with the process exam. But actually, he did tell me that he passed, but he still had to go back and do the machinery one because that's what his company wanted him to have. So you can do the machinery, you can do automotive, if you're in automotive industry. 1508, if you're a designer, designing products, you can do the safety hardware development or the safety software development. And of course, as we've mentioned already, the cybersecurity. So these are the types of exams that you can sign up for. So just to summarize all of this, 1511 has put more emphasis on competency of personnel and contractors. So not just the end user personnel, which end users would be the final end user and the engineering companies. It would also be any other companies that are used to help with doing functional safety. In other words, if you have a one-man band that says they can do facilitation, they have to prove they're competent to do that. The intent, of course, as I mentioned, is to reduce the systematic faults due to personnel competency issues. This, even today, 7 years or 8 years, no, 9 years now, 9 years after the new release of 1511, there are still issues with competency. People not being properly trained, not being competent to perform the work. So there's more rigorous requirements on this. And of course, on the competency assessment and the competency tracking. Oops. So competency development programs need to be put in place. That's basically a fundamental requirement. And because we have to have evidence that we're tracking it. And we are also performing those periodic assessments. As I've said to you, the standard doesn't tell you how often to do it. It just says you need to do it. So you can determine the frequency, how often you do that. So that's the meat and bones of this presentation. For those of you that don't know me or don't know Exeter, let me just briefly explain. So my background, I go all the way back. I've been in the industry for 48 years now, and I started off as a hardware software development engineer working in the controls and automation space, and then I moved into safety, designing ESD fire and gas and addressable fire systems. At Exeter now, I've been here 13 years. I'm responsible for our end user services, as well as being one of the primary instructors on the functional safety class, the CFSE 100. I also teach the CS 100, which is the equivalent cyber class. And I've written the book, Functional Safety for Managers, what managers need to know, because this is an area that is definitely one that needs improving for the knowledge of management supervisors. They need to know this. They need to know what has to be done. And there's another book that I wrote called Managing in an Automation Company. So in Exeter, this is our 25th year. We started in 2000. We started doing just product certification for safety, but now we do the cybersecurity certification. We do people certification, as I mentioned, the CFSE board, it's independent, does the certification. The lifecycle services is my division, where we provide support for the functional safety lifecycle, the cybersecurity lifecycle, and the alarm management. And then we have the enterprise tools, which support the services and the certification. We are global. We have offices all around the world. And the nice thing about those three, the functional safety, cybersecurity, and alarm management, they are to a certain extent industry agnostic, so you can apply them to any industry. So we've worked in mining, we've worked in oil and gas, of course, chemicals, pharmaceuticals, food and beverage, machinery, robotics, automotive, and so on. I always encourage people to use our website because there's a lot of free material on that. These webinars are recorded as YouTube videos that are available through the website. There's also these reference books. And if you are going to go on and do CFSE or CFSP, I highly encourage you to get the study guide as well as this practical SIL target selection book. And if you're doing SIS design, then I recommend having this safety instrumented system design book. It's very, very useful. There are also white papers and case studies that are free and available. From the tool point of view, the Excellencia tool, some of you may be familiar with that and are using it currently, but basically we have these particular modules that follow through the life cycle. Once you get information into any one of these, it's available to the others. So we can go from doing the hazard and risk assessment, both either from the safety side, and we have the cyber equivalent that can use the same tolerable risk that safety uses, which is our cyber facts tool. And then you can feed into the LOPA tool. So you can automatically pull any scenarios that you've identified as you go through the PHA as a LOPA candidate, and then do the lead protection analysis with the SIL selection. And this feeds into the SRS. So at the end of the analysis phase, we end up with an initial SRS, which we then use to develop the CIS and its CFS. So the silver tool is used to do the modeling of the CIFs and the calculations. And then if you wish to do a life cycle cost, you could do the life cycle costing for the CIS. And then this information gets built into the design SRS, which will be used to actually create the system. There's a proof test generator module, which will look at the CIS and what specific components you've used and create a proof test based on that. The SIL alarm tool can be used to create a master alarm database. So if you either use that standalone, or if you've identified alarms here as layers of protection, they can be pulled into the SIL alarm tool to start creating the master alarm database. And then finally, we can transfer all this information into the SIL stat tool, where you would use that to do your performance recording. So all your field performance information would be in there, because let's not forget, we're supposed to be doing FSA 4s according to 1511, which is comparing the performance we're measuring with the original design criteria to see whether our performance is matching or not.